Last Thanksgiving, my mother trusted in my hands a brahmi plant. This plant is really hard to take care of. You have to be watching it every day. You gotta water it, make sure everything's going good. I am an electrical engineering student. I don't have this kind of green thumb, and several months later, you can see what happened. I needed a helping hand. So I decided to design my own gardening assistant. I used ESP32 to set up an Internet of Things like Home Assistant sensor guy, and what it does right now is it can check the temperature around my plant and how much moisture is in the soil, and I can use that to be like, oh my gosh, I need to like water it. It'll basically be able to remind me when I go on the house and like, oh, I need to check. You know, it can do all the smarty pants planting, gardening stuff for me. So I'll show you how I went and designed this thingamabob. Setting up the breadboard prototype. First, I had to breadboard the machine and prototype it. As you can see here, I set up a test for just the soil moisture sensor, which is the most important thing for me right now. And as you can see, I can output the moisture levels on my OLED screen. Testing the 915 megahertz LoRa radio module. The radio is able to transmit. My SDR is tuned at 915 megahertz, which is the frequency where my antenna is transmitting at. Every time a packet sends out, we get that signal, basically. As you can see, it's about the same time. Yep. So the radio works. Now I need to figure out how to take this and turn it into numbers so I can read it. Yeah. I basically programmed the ESP32 to look at serial communication, and I was able to get messages between the two nodes that I had set up that basically sent count 1, and I could count the messages. Unfortunately, that's where the radio stuff ends for this time. I made a hardware issue where I put a very, very small footprint for the radio, which is I just can't fit the module on it. It's 1.27 millimeter pins, and this is 2.54, and so that would be the last of the radio for this. But hopefully I can bring it back next time and make bigger pins so that it actually fits. Designing the actual basic first PCB iteration. I just made some basic design where it's just a bunch of pin headers really for all the components I already have. I just stick the breakout boards onto them, and then tried playing around with some stuff to learn how PCBs work. Then I had a week-long waiting period for it to arrive because, shipping just takes so long. Yeah. Unboxing the PCB. also made another mistake where I made it so that I switched these guys, the lines, and so it should have been like flipped. So I had to pretty much put the ESP32 on this side, the opposite side than the side that I originally planned it to, but it works. So now soldering the PCB and assembling the board so I can test it. Now I have to try to test the code and install the firmware, test the code, and see if I can connect to Home Assistant and actually see the data. I think I have to wait a second because last time I was almost too. OLED is working. Now this is working. Let's go. Yippee! It works. The thingamabob is able to do the basic tasks I wanted it to do. Like I can get all the data onto Home Assistant, and I can see it using Wi-Fi. I don't have to, walk over to the gardening plant. I can just be like, there's no more water. I'm gonna water it later. So yeah, it worked out. There's a lot of problems, but I got it to work. And hopefully next time I work on this project, I can get it to work without Wi-Fi, or maybe, maybe get a better, make a better PCB. I don't know. Yeah, but thank you for watching. God bless.